If you are new to the channel, then subscribe the channel and press the bell icon for further notification.
Okay student, welcome you all to this new lecture in intermediate level where you are building concepts on definite integrals. So in this lecture we will be seeing some of the recurrence formula, that shortcuts for your JEE main and advanced level, some trigonometric integration, some properties of a definite integral, and then Leibniz rule or derivative of integration or derivative of antiderivative. Okay, then let's see this. Okay, so in definite integral, intermediate and advanced level, suppose f and n are suppose m and n are positive integers. So if you remember this formula 0 to 2 pi sine mx into sine nx, it will be 0 if m and n are not equal. It can, all thing can be proved, but you can remember it as a formula. That will be helpful for your main and advanced question. And if m and n are equal, then the answer will be pi. It can be easily done. Sin A, sin B formula you apply, then you do, it will be coming. Similarly, cos A, cos B, similar formula. So you can remember it this way. But if it is a sine cos, then it is obviously 0. Similar, it will be 0 or pi depending. If it is not similar, m and n are not equal, then it is 0. Not similar, 0. So if it is not similar, then it is always 0. Now 0 to pi by 2 sin m or 0 to pi by 2 cos m. This is the formula. This can be more generalized here, but you can remember it separately also. It starts from m, then 1, m minus 1, m minus, denominator it is m minus 2, m minus 4, even difference you subtract, and here odd numbers you subtract, into pi by 2 if m is even. And if m is odd, then this pi by 2 will not come, rest remains same. Because if it is odd, it will finish at 4, because from number 5 if you deduct 1, so 5 minus 1 it will 4, 5 minus 3 it will 2, it will stop there 2. If it is even. So don't think that stopping point. You just remember the upper one will be 1, 3, 5 like this way, and the denominator will be all even. It will be pi by 2 if you multiply, then when m is even, when not there is no multiplication. More general approach is this one. If sine cos both is there, you can think it of this way, n is 0 here, then it will be this formula. If m is 0, then this is the formula. So if n is 0, then same. In the numerator it will odd difference. So from m also come, from n also come. And in the denominator it is actually, now it is not individually, it is addition of these two, m plus n, then m plus n minus 2 minus 4. Again both even, then it is pi by 2. Otherwise if one is even also, then also it will not, pi by 2 will not come. Both is even, then it is pi by 2. Otherwise no pi by 2, something of this fashion. So these formulas are known as recurrence formula, reduction formula, or Wallis theorem, whichever way you can remember. But that will be helpful for your joint exam. Now, if it is a monotonically increasing function, we have seen it is continuously increasing, then b minus a into fa, fa is this position, b minus a into fa is this area. So this area is smaller than your required area, we have seen, and b minus a into fb is this area, the larger one, this rectangle. So that will be obviously more than your required area, that is area under the curve. And if it is a decreasing area, then b minus a into fb, because this is the minimum value now. So minimum into b's will give you this area. So obviously the required area is more than this, and this area maximum into this will be more than the required area. Now this is another formula, derivatives of antiderivatives. That means derivatives of integration, which is known as Leibniz rule. So you can remember this way, ddx of this integration, any function where the function is changing from gx to hx. So the output will be a variable of x. It is a definite integral, but here these are not integers, these are the functions of x. So in place of t, if you put x, it will be a variable of x, then you differentiate x. Now how to remember it? Now you can think this integration differentiation get cancelled. So this original function comes back. So it is the original f. Now because it is not now t, inside there is hx, because what is the upper limit? This will f into upper limit minus f into lower limit. So f into upper limit is this one, because it is differentiation. So you have differentiate that's one, this integration differentiation get cancelled. Then you have to integrate this inside one also, chain rule. So that way h dash into x minus lower limit, this again cancels, so original function back. This differentiation is done, because you have done the differentiation, that's why it is coming back to original, and you do the differentiation inside, that is chain rule. So that's why this is like this. You can remember it this way. This is another important formula.
If you like the video, then press the like button and please give your valuable comments in the comment section.